Okay, so hopefully by now we're comfortable with addition of integers, right? So like if you have plus 13 and plus minus 7, negative 7, this means the same as 13 minus 7. So for example, it's 6, okay? So visually, for plus, it means we're going 13, right? 13 to the right. And then if you go left 7, you end up at 6. That's what that means. What about subtraction? What's a good way to visualize subtraction? So we want to visualize subtraction. Okay. Now, before I start, okay, if I draw an arrow this way, okay, let's say this started from 0 and ended at 4. This means plus 4. There's two things that this arrow describes. The size of the distance that we traveled, plus means we're actually going right. If I write minus 4, that means we're going this way instead. But if I actually put this on top of this line, it's exactly the same length, except, right, the arrow is pointing the other way. So let me give it some name here. This is the tail end of the arrow or the ray, and this is the head of a ray. So this is called, okay, so we call this, right, with a tail, with a head, we call this a vector. Okay, so it's just an arrow that has a beginning and ending, and it's telling you which direction it's going to, and it describes the size. Okay, so hopefully it's pretty simple to understand that this is plus 4 and the difference of minus 4 is just going the other way. Okay, so how do we do something like this? For example, plus 10 subtract, let's say, negative 2. Well, this is how we do it. 10, let's locate 10. 10 will be about there. Where's negative 2? It will be about there. And what we do is, okay, we mark it like that, and you always get the beginning. Okay, this first number as your head of the arrow, and this is the tail of the arrow. Okay, so that represents the difference. So plus 10 subtract negative 2. What's the magnitude of it? What's the size of this arrow? It's 10 plus 2, so it's 12. And it's going right, so it's plus 12. So the result of this is plus 12. Isn't that cool? Okay, so let's do another one. Let's do like a minus 4 subtract plus 7. Okay, what does this mean? It means our head is at negative 4 and our tail is at 7. Okay, so it's like this. Okay, so which way is it going? It's going left, which means our answer is going to be negative. What's the size? It's 7 plus 4. The size is 11. So negative 4 subtract positive 7 is indeed negative 11. Okay, one more. Let's do negative 5 subtract negative 10. That looks very symbolically confusing, but this simply means here's negative 5 and here's negative 10. Here's your head, okay? This is the tail. So it's got to go like this. Do you see it's going right? So the answer is going to be positive, positive. And the size, do you see it's 5? So it's plus 5. Okay. So suppose I ask you to draw a picture of, for example, negative 7. That means it's going left and it has a size of 7. So what subtraction of what two integers will represent negative 7? Well, let's say this is 2. Okay, 0 will be here. We need to go 5 more this way to get 7. So this should be negative 5. So negative 5 subtract positive 2 would equal to negative 7. So I'm just doing it backward. I'm creating that question from the picture. Okay, so hopefully that makes sense. And you can now visualize the subtraction of integers using vectors.